Hello, everyone. Good evening. While the presentation is being set up, um, I'm Radhika from Shadow Robots, and Rich was supposed to be here, so you can see Rich Walker, Managing Director, on the presentation. But unfortunately, he's unwell, and I'm trying to step in and fill in those big shoes. I'll try and make sure I'll make your time as worthwhile as possible, if not as entertaining as Rich. Um, Today in the morning, I must say, at 11:30, I was just dreaming about this adventure. Next week, this time, I'll be on the plane going to Kilimanjaro to do the trekking adventure. And I half resigned and just half focusing on the work. And I get this message from Rich saying, I'm actually really sick. Radhika, can you do the presentation on my behalf? At the London Robotics meetup, Napo and Villas have requested for me to step in and do it. So I said, Rich, you can't do this to me, but unfortunately, I'm here. But it's nice to see all of you, and nice to see all the usual suspects here. So yeah, let's get going with what's the story behind building robot hands. So Shadow Robot, as the title suggests, we are a company who are designing and developing and building robotic hands. And we have been doing this for more than 20 years. So here's a little bit about ourselves. As a company, it started in 1997. But before that, there are some amazing stories to share. Probably you can find some of them on the blogs of our website as well. It started off as a hobbyist group, and one of the founder directors, Richard Greenhill, happens to be a hobbyist photographer. He didn't have any background in technology, but all he wanted to do was find better technology to make his cameras work better and make him enable to capture the images better. So in this hunt, he came across some high school goers who were exhibiting something that they made in a science fair, and invited them to join him at his house. And they started working in the attic of Richard Greenhill, starting and trying to build things. And apparently the first thing they built was biped robot. And as they were about to exhibit it and launch it, they realized that Honda has launched a biped robot. So they didn't want to go head on with Honda, and then went back and decided what else can we do that can be exciting and keep them motivated. And eventually they came up with one of the most complicated organs in the human body, which is the human hand. And they decided to build human hands, and that's the story. And all these high school goers, they stayed with the company, and one of them happens to be Rich Walker, and the other one is here. Should wave your hand, Hugo. He's one of our senior R&D engineers, and all of them went back to study at university and then came back to stay with the company. Maybe Hugo, I don't want to put the focus on you, but if you want to share any stories or if I'm saying anything wrong, stand up and say, don't say that. And maybe you can share the stories later. Right now we are close to 40 staff, and most of them are robotics engineers, either software, hardware, or R&D. And we have been selling our hands to clients across the globe. We have a global distribution network, and we have a network of collaborators and partners in various countries and continents. So this is a glimpse of the client list. Here you can notice that We work with big organizations like we have supplied hands to NASA, ESA, and more recently to JAXA, which is the Japanese space agency. And we have supplied hands to other big companies like Hitachi, and also to research organizations and research labs at universities, global universities like Carnegie Mellon, UCL, etc. Having said about our links with big organizations and global universities, I must also say that we work with startup companies as well. On the bottom right-hand side, you can see SynTouch. They supply the tactile fingertips for robot hands. So, moving on, right from the beginning, Shadow has stayed as a research-focused company, and we have a strand of research always ongoing, be it internal R&D or be it other collaborative funded projects. This is something that keeps us going and keeps us motivated. This is slightly older information about our participation in Innovate UK projects. Yes, last year I think we were in 7 Innovate UK projects and 3 Horizon 2020 projects. The European proposals or the European project side of things is still valid, but with the Innovate UK, I think some of them finished and some of them started, so I don't have the count. But apart from these, we are also involved in 2 big R&D collaborations which are happening with big clients in AI side of things, as well as we being recognized as grasping and manipulation experts in the robotics world. We are approached by these big clients to engage with long-term projects with us, where we are trying to develop exciting pieces of technology for them. So hopefully we'll have something exciting to share in next year or so. And here you can see the latest work. This is a flagship product, which we call it as Shadow Dexterous Hand. This is a hand which is one of the most advanced robotic hands that is commercially available in the market, which matches the human dexterity and manipulation ability very closely. So the images that you see at the bottom are the outcome from the work that we are doing with OpenAI, which is a Google company. And there is a little story behind that, probably, something funny. They came to us, I think, a couple of years ago, saying we are doing research in machine learning and developing some reinforcement learning algorithms. And we want to test them on, test those complicated algorithms on simulation models of your hand. And they said, this is what we are going to do. So eventually we thought, okay, we'll give them access to our simulation models. Some of them are open access, and we said, okay, you're free to use. And we thought, okay, they're never going to come back to us. They're never going to succeed working with them. But surprisingly, after a couple of months, they came back saying, we succeeded in testing our algorithms on your simulation models, and now we are all excited to work with them on your actual hardware. So this was a big surprise for us as well. And when they came back to actually test on the hardware, I don't know how many of you are aware of or know Shadow Robot or follow Shadow Robot. We have some interesting videos on our YouTube channel. Maybe you can just explore it when you go back home. These are some of the complicated movements which the hand learned by itself using the reinforcement learning algorithms that OpenAI has designed. And the most latest one is our hand, a single hand solving a 3x3 Rubik's Cube by itself. It sounds really painful, but if you have a look, maybe you'll enjoy watching that. So this is something about autonomous grasping. This is something that came out from one of the projects which we were involved in along with National Nuclear Laboratory, NNL, and other research partners like TWI, the Welding Institute in Cambridge, and University of Strathclyde. So as you can see here, one of robotic hands is trying to pick up an object and place it. So this is a very basic GIF out of that project. But essentially in that project, the idea was to chop off alpha contaminated glove box into small pieces and using shadow robot hand, pick up those pieces, pack them away in smaller containers so that it can be stored away as intermediate level waste or low level waste. So this is one of the use cases that Sellafield, the nuclear end user in UK, is trying to solve in the nuclear decommissioning side of things. And this is something we demonstrated in the feasibility study in simulation. The unique value add that Shadow Robot Gripper has brought into this project is the laser cutter, which is developed by another partner in the project, can chop off the glove box into random shaped pieces, which are of different sizes, shapes, and weights. And our gripper offers the adaptability to pick up these pieces of random shapes and sizes and pack them away into containers which can be stored. And also you can see other bits of information here. All robotic hands are ROS compatible, so most of you are roboticists here, so you must be knowing about the robotic operating system. And our hand could be integrated onto or mounted onto many commercially available robotic hands. Obviously, it becomes easy if they are ROS compliant as well, but even otherwise, I think our engineers are clever enough to make it work. So what's next? So we have been designing these robotic hands and supplying them to the research community for a long time. And we stayed as a research product, I think, pretty much for majority of the number of years that we have existed. But in the recent past, we have also been exploring about how can we make use of our robotic hand in the real world scenarios. So this brought us back onto thinking what else is a skill apart from designing and building robot hands. So we figured out that with our participation in lots of collaborative R&D projects, be it funded by Innovate UK within UK or European proposals, we were also playing the part of integrating various other robotic technologies and designing a holistic system which can solve a real-world use case. So we thought, why can't we use skill of also being a system integrator along with just designing robotic hands and come up with something which can solve the real world problems. So out of that thought comes this tactile telerobot. So here you can see at the bottom, we teamed up with two other companies, both of them being startups. One is SynTouch, which designs the tactile fingertips. So if you can see the green or teal bits on the tips of shadow robot hands, they are the BioTacs. Some of you must be working with them or experimenting with them in your own robotic projects. So those are the ones that are transmitting the tactile information. And Haptex is the glove, haptic sensorized glove that is made by the company. I think they are Seattle based. And with this system, you can see there the person is wearing the Haptex glove and trying to control shadow robot hand, which can do various things, and the tactile information will be transmitted to the person who's wearing the glove. So how can this tactile telerobot be used in real-world situations or solve the real-world challenges? So this is, apart from stacking cups, I think we can do a bit more than that. This project, or the collaboration between SynTouch, Haptex, and Shadow, is the outcome of a project that was funded by ANA, which is All Nippon Airways, a Japanese air fleet manufacturing company. They came to us, I think, 2 or 3 years ago, saying they have this dream idea about making the telepresence a reality. By this, they mean that a person sitting in one location should be able to experience everything that is happening in a location that they desire to be in. So with this dream idea, they came to Shadow saying, we are excited about this and we want to launch this as an X-Prize competition. Has anyone heard about X-Prize competitions at all? Yeah. So they wanted to launch this as an X-Prize competition, which is where people, either organizations or individuals, will come together with the technology to solve the dream or the aim that has been posted into the challenge. So when they came to us, we were already working with SynTouch and integrating the BioTac sensors on Shadow Robot hands. And we met Haptex in several events where they were exhibiting along with us. So we thought, okay, why don't we come together and try and develop a system which can make the teleoperation or telepresence possible. So we were successful in designing the teleoperation system, and this was launched as Avatar X-Prize competition later on, where we were recommended as one of the hardware suppliers for all the people who are participating, and we are moving on from there. So this is again the same thing that I mentioned there. So here, Shadow Robot hand is one of the parts in the tactile telerobot, where the actuators sit on the Shadow Robot hand. And the sensors, the BioTac fingertip sensors that are supplied by SynTouch, they are integrated onto the hand, while we are using the commercially available vision systems. Currently, we are using HTC Vive, I think. And Haptex is providing the Haptex gloves. We'll talk a little bit or learn a little bit about what is involved in each of these components of the tactile telerobot. So going back to our flagship product, which is the Shadow Dexterous hand, here you can see a lot of internal details about what are the sensors we have, what are the kind of connectivities that it can enable us to connect with other robotic components. So here you can see that we've got many position temperature sensors and pressure sensors, and we've got tendons that make the number of degrees of freedom that we can offer possible. So this is, again, designed and built by Shadow Robot, so completely owned by us. So this one, and next comes the sensors, which are both the other components, both Haptex and SynTouch, provide the sensing information. So what information usually humans perceive from tactile sensing? Anyone has any ideas or any answers for this? Fingerprints, yeah. Vibrations, that is one. Temperature, yes, that's good. Pressure, yeah. So I think we got mostly everything. So force or pressure is one kind of information that a tactile sensor usually offers. The next being vibration, which is quite useful for a human being to sense it by touching it. And the third one is temperature. So um, these are the slides that the content of which has been provided by the SynTouch owner, Jeremy Fischel. So I'll stay quiet and let you read here. But all that I can share is the green or the teal fingertips that you have seen, which have a curvature here, they provide you with 3-axis force sensor, torque, and the point of contact. So why do we need force when we are using the fingertips, or how do the humans use the force information that we perceive from the tactile sensing? Is mainly to detect the hardness of the object. So when a human touches an object, the force information gives how hard the object is, and that's how they perceive what kind of object they are touching. So moving on with the vibration sensing, first thing I learned when I started at Shadow is how important the fingernails are for human beings. Before that, I never realized. I thought it's only for safety and just to take care of your fingers not being hitting something that we have the nails. But apparently, nails are required in order to detect the shear force and also to detect the slip sensation. The fingerprints are required. So here you can see that the vibration sensing, when we touch an object and slide along it, will give us the sense of detecting the slip as well as identifying the texture and properties of the object that we are trying to grasp or manipulate. So here are some publications by Jeremy Fischel, whose PhD outcome were these biotags and the SynTouch. So if you're keen, maybe you can go through his website and get more information on that. And the third one is the temperature sensor, which is as soon as you touch an object, the tactile information we get, apart from force and vibration, is the temperature. So depending on whether the object is hotter or colder when compared to the body temperature, I think the human decides how much area of contact to make with the object to pick up the object successfully. So moving on, why is tactile sensing important in robotics? So humans have got many many senses, vision being one, smell, and various other senses like hearing. So why do we need tactile sensing? What is it going to add apart from all the other senses that we are trying to use in various technologies that we are coming up with? So here you can see that static contact gives us what the temperature is, and the pressure, like one of you already mentioned, the pressure sensors give information about the hardness, and the vibration gives us the surface texture. And the bottom half, I think part of it you can manage with vision as well, but if you have tactile sensing together with the vision, you might get more information about what's the weight of the object or what could be the global shape, because the currently available vision systems, I think they are not quite successful in scenarios where the depth perception is more clearly required, or when the objects are shiny metal parts, where a lot of the systems that are available in the market fail. So in these cases, having tactile information always helps you in perceiving the object better, and then picking it up or grasping and manipulating it in a better way. So here you can see one of the failed examples of a parallel gripper trying to pick up a can where it has damaged the can. So how can the robots with tactile sensing help in the industry? So there are 3Ds mentioned here, where robots with tactile sensing could be much more useful than robots without tactile sensing. So, but there are, in fact, 6Ds. So dirty, dangerous, and dull. Any guesses on the other 3Ds? No? I have to go back to my notes as well. But I have made notes. So the dull, dirty, and dangerous are the first three key things that come up to everyone's mind when you want to, when you don't want a human to be doing it. But the other 3Ds are a demanding job where you require all the cognitive abilities of a human to be focusing in order to do that or execute the job, which can be okay for the first few hours, but as the hours progress, the human starts getting exhausted, and that's where the errors seem to creep in. And the other one is distant. So can you think of any applications where a human has to execute things in a distant location? Sorry? Yeah, Mars exploration, that is one thing. And anything more local, more on Earth? Underground, yeah, that is one good example. Undersea, yeah, for the oil and gas applications, people need to be flown in to the offshore sites, maintenance sites, which is quite expensive as well as quite dangerous if there is an emergency situation there. Those are the examples where you don't want a human to be doing it, but at the same time want to have a robot which can use as many available senses as a human has in order to execute the task. And the third one is distributed. Any thoughts on what could be distributed applications where robots could be useful? Yeah, warehouse logistics, that's a very good example. So let's assume that in next few years' time, if all the warehouses are automated with the Amazons and others that we are seeing, let us say there is a maintenance task. You need to have a human to be monitoring that, and you don't want a human backup in each single location of the warehouse. Probably having one human monitoring several warehouse sites and having using the teleoperation or remote manipulation systems in order to fix the maintenance tasks could be one of the options. And obviously you can see here nuclear decommissioning, which falls into the dirty and dangerous as well. So the other application areas, some of them are listed here, and I can share some examples of what we are doing. With the teleporting skills, the example I've shared is the work we are doing with ANA, which is All Nippon Airways, and this is where we realize the telepresence side of things. And dangerous or inaccessible environments, again, one of you was quoting about the space. The biggest research challenges that people are trying to solve in space are especially the debris removal in space, with lots of countries now having the ability to launch satellites. The debris in space is also increasing, just like the global warming we are facing here. Space is also facing these situations. And other thing, deep sea was already mentioned. So deep sea maintenance tasks where you have to go and inspect what's happening to oil pipeline or something. If there is an accident, send in a robot to do that. nuclear, I have shared our project called Alpha Glow Box, where we tried to decommission a glow box using remote manipulation and machine learning. So this is another area where we are working. I've quoted an example and showed some images about our work with OpenAI. And there are many key algorithms, and also the other project we are involved in is the Human Brain Project. I think that is a project where people are developing many AI techniques in order to realize the neurorobotics research, and they are developing a platform where many robotic components could be included as simulation models, and the researchers, the neuro researchers, can test their algorithms on these simulation models on the platform. So that is another project that we are involved in apart from the OpenAI. In the semi-autonomy and the efficiency side of things, this is something that a lot of, I think many sectors and markets are keenly looking into. They want to use robots, but at the same time, they don't want to hire roboticists in order to carry out or use the technology or equipment. They want their normal employees, the regular ones that they recruit, to be able to learn how to use the system. So in these cases, having high-level instructions where a person can understand, okay, move this piece from here, from point A to point B. That is something the person would see, would give in keen as instruction. And the system should be able to break it down into low-level tasks and instruct the robot or the system to execute that on its own. So that is the semi-autonomy side of things, where a lot of research is happening, and we are involved in one of such projects as well. So this is a video, if you can play. successful in the ANA project, Avatar Express project. We were invited to showcase our technology in Amazon Remars, which is Amazon's internal showcase event. And that's where Jeff Bezos tried to play with our tech, which was cool and earned us a lot of social media attention. So in conclusion, how do we make use of tactile sensing? Why is it useful for lots of teleoperation scenarios as well as robotic applications? Is most of the things I think you can get away with just having a good vision system. But I was reading through an article or a research article which obviously Jeremy Fischel from SynTouch shared a few weeks ago. There was a research conducted where the participants were split up into two different groups. The first ones were asked to execute a task blindfolded, and the second group was asked to execute the same task without, their hands were covered, so they don't know where the object is or what is the kind of task. They were just shown their task on a video and were asked to execute the task not being able to see their hands. So apparently in the first research group, it's just using the tactile sensing. And in the second one, they have the vision to perceive where things are going and how to do it. But apparently the research outcome is that the people who are blindfolded, they were able to touch and feel the objects and then execute the task well. But the people who were doing it with the help of vision, doing it remotely, they had longer duration and longer learning times in order to do it. So these are the application areas where we are looking for. So today afternoon, we had a workshop meeting with one of the big oil and gas companies where they are coming up with similar kind of situation where they have these offshore sites where people need to do some rounds, operator rounds they are termed as. So it's just regular inspection, going in, checking the number of inspecting the valves, turning any valves, or switching on, pushing the buttons, or just even listening to how the machine is running, if it is sounding anything different. So the human is trying to use all the senses in order to find out whether things are running fine or not, and they just come back doing these inspection rounds. So these are the places where people have to go in, put their health and safety at risk, and carry out the task. So those are the jobs which a lot of market sectors and big organizations want to automate using robots. So teleoperation system and teleoperation system being enabled with various sensors could be a good use there. So yeah, that's it from me. And I'm happy to take any questions. I'm here.